We're going to finish off our discussion of exoplanets by looking at how our discovery of exoplanets has affected the nebular theory. And you can probably guess how that's going to go, since the title of this lesson is When a Theory Fails: Exoplanets and the Drama of Our Solar System. So for a quick review, remember nebular theory claims that our solar system began as a giant nebula about 5 billion years ago that gravitationally collapsed, flattened out, heated up, so that the center became the sun and the planets accreted out of the planetary the nebular material in the outer regions. We had looked at how we use the scientific method to come up with this hypothesis, originally a hypothesis, how we combine empiricism, which is observations, to help answer our question about the problem, and we add into that general knowledge that we already knew about space and science in general. And so we saw that a number of these observations we combined with Newton's law of gravity, spectroscopy, the gas laws, angular momentum, importantly the kinetic molecular theory, and so on, and we used deductive reasoning to come up with the nebular hypothesis. So that took us through the scientific method up to this point, but remember that a hypothesis then needs to be tested using deductive reasoning to make an observable prediction, and then empiricism to actually see if you can actually see that predicted observation. And we saw that with a number of predictions and successful observations for nebular hypothesis, and that is why we say that nebular hypothesis can now be referred to as nebular theory. But we had some problems with nebular theory, or some incomplete areas. For one thing, there were some features of the solar system that nebular theory does not explain. For example, the existence of the asteroid belt, the existence of that giant cloud of icy material that surrounds the entire solar system called the Oort cloud, and this period that I've mentioned a couple of times, the late heavy bombardment, which is a time period well into the formation of the solar system when suddenly material started to fly all over the place and smashed into the developing planets and moons.
The relentless bombardment gouged out craters thousands of miles wide, and the hits just kept coming for at least 200 million years. Today, billions of years of erosion and shifting plate tectonics have erased any trace of the cataclysm from the Earth's surface. But it's a different story on the cratered face of the moon.
We can see very clearly its record on the face of the moon. The lava-filled basins were formed during the giant impact events that occurred during the late heavy bombardment. And so we know that large objects hit the Earth during this time.
So we have these at least three features that nebular theory hasn't explained yet, including this late heavy bombardment. There's another problem too, though, with nebular hypothesis, and that is that it's based on a single example of a solar system, on just our solar system. And so we need to be aware of the fact that we may be committing a logical fallacy, the hasty conclusion fallacy, drawing our conclusions on too little evidence.